the last lecture we have completed about ionic bond. You know, ionic bond is formed by the transfer of electrons from the more electropositive to more electronegative atom. There is a formation of cation and anion, and there is electrostatic force of attraction or Coulombic force of attraction between oppositely charged ions, and that is called ionic bond. Now, covalent bond. Covalent bond is formed by the mutual sharing of electron. The bond, first of all, the bond formed between non-metals is generally covalent bond, and this type of bond is present in most of the compounds. It covers large number of molecules. So there are many theories which explain the chemical bond which is called covalent bond. So there are different theories. To explain covalent bond. So for the explanation of covalent bond, there are different theories. First theory is given by Lewis Langmuir. That is called Lewis Langmuir theory. Second theory is Valence bond theory. And third one is molecular orbital theory. All the theories are covered in this chapter. Lewis Langmuir theory, that is most basic theory about covalent bond, and then we will discuss Valence bond theory, and at the last we will discuss molecular orbital theory. So first of all, let us discuss this one. Theory about the explanation of covalent bond. Actually, the Langmuir, in collaboration with Lewis, introduced a new type of chemical bond known as covalent bond. And according to Langmuir and Lewis, the bond formed by contribution and mutual sharing of electrons is called covalent bond. The bond formed between two atoms, and these two atoms may be similar or different. Bond formed between two atoms by contribution and mutual sharing of electrons is called covalent bond. And you know, they may share one pair or two pair or three pair of electrons, and accordingly they leads to the formation of single bond, double bond or triple bond respectively. Means if two atoms Say if we have A atom, each atom contribute one electron and share with each other, then there is a formation of single bond. If A atom share 2 electrons, B atom also share 2 electrons, then there is a formation of double bond. A atom share 3 electrons, B atom also share 3 electrons. Then there is a formation of triple bond. That means if atoms share 1 electron each, then we have a single bond between two atoms. If they share 2 electrons each, then there is a double bond. If they share 3 electrons each, then there is a triple bond between two atoms. But what would happen when they form single, double or triple bond? You know, there is more bonding in triple bond than double than single. That means A atoms are closest in triple bond and farthest in single bond. Same is the case with different atoms. If atoms are similar, they are called homoatomic molecules. Homoatomic means if there are only 2, then that is called homodiatomic molecules. If there are 3, they are called homotriatomic molecules. 3 similar atoms. Okay? Like O2 is homodiatomic. O3 is homotriatomic. And if atoms are different, they are called heteroatomic molecules. Means different atoms, they are called heteroatomic. Same atoms, they are called homoatomics. Okay? Like A single bond B, A double bond B, A triple bond B. They are heterodiatomic. They are homodiatomic. I think you would understand homodiatomic, heterodiatomic. Two atoms in the bond, if they are different, they are called heterodiatomic. If two atoms in a bond are similar, they are called homodiatomic. Okay? Now let us discuss H2. This is the most simple homodiatomic molecule. Homodiatomic molecule. Now, in H2, tell me how many bonds are there? Single bond, because each hydrogen contribute 1 electron. Okay, so you can write it like this. So each hydrogen has attained noble gas configuration of helium. Okay, so this is called Lewis structure. If there are dots representing the bond, then that is called Lewis structure. And if there is a line, single line, double line, triple line, or we can say dash between single dash, double dash, triple dash, they are called Coupe structures. Not Cooper. R is silent. That is called Coupe. I can write in Hindi. Coupe, okay? R is silent. If there are lines, or we can say there is a line between two atoms, single line, double line, triple line, to represent the bond, they are called Coupe structures. And if there are dots, electron dot represent Lewis symbol. So if there are dots representing the bond, that is called Lewis structure. Okay? Done. So H2 likewise O2. Oxygen has atomic number 8. It needs 2 more electrons to acquire noble gas configuration. It has 6 valence electrons. So 2 electrons shared between each other. So there is a formation of double bond. What about fluorine? F2. Only one, because fluorine has atomic number 9. It has 7 valence electrons. If it shares 1 electron, each fluorine will acquire octet of electron. So fluorine, there is single bond. Okay. What about nitrogen? N2. Nitrogen, it has atomic number 7. So nitrogen share 3 electrons because it is 2, 5. So when it share 3 electrons, each nitrogen acquire noble gas configuration, and it is like this. Yes, what about methane? Carbon, because carbon has 4 electrons, valence electrons, so each fluorine share 1 electron with hydrogen. So it complete duplet of each hydrogen and octet of carbon. Okay, so in this way, this is methane. Okay, so in methane, this is Lewis structure, and this is Coupe structure. Okay, because first time Coupe let us know that if they represent this one pair by this line, it will be okay. Means these lines represent the bond. This dash represent the bond. That's why they are called Coupe structures. What about H2O? H2O. In H2O, oxygen has 6 electrons. Hydrogen will contribute 1 electron each. So it will complete duplet of hydrogen and octet of oxygen. So in this way, it is water. Okay. Now ethane, C2H6. C2H6. So C2H6, it is CH3, okay, C2H6 is CH3, CH3, or it can be represented as this is coupe structure, or it can be written as each carbon has 4 electrons, 1 electron shared between carbon, and 3 electron of each carbon share with 3 hydrogens. So each hydrogen has its duplet and each carbon complete its octet. Okay? Yes, so what about C2H4? C2H4. So in C2H4, it is CH2, CH2. Each carbon form 2 bonds with hydrogen, so 2 left. So there is a double bond. Carbon, double bond carbon, hydrogen. That means carbon share each carbon share 2 electrons with 2 hydrogens. So each carbon left with 2 electrons, and this way each carbon completes its octet and each hydrogen completes its duplet. For hydrogen, duplet. For other atoms, there is octet. Okay? Now, that means there is a double bond between 2 carbons. Now, C2H2. So, CH, that means there is only 1 bond formed with with hydrogen. Therefore, there are 3 bonds between 2 carbons. Like this. That means each carbon share 1 electron with hydrogen and 3 electrons are shared between 2 carbons. So each carbon has octet of electron, each hydrogen has duplet of electron. That's it. What about NH3? Okay, PCl3. So in NH3, nitrogen share 3 electrons with 3 hydrogens, and nitrogen has how many valence electrons? 5. So it is like this. Each hydrogen has duplet. So it is like this. PCl3, again each chlorine share 1 electron, and each chlorine has total 7 electrons. So each chlorine has octet of electron. Even phosphorus has octet of electron. So in this way, PCl, Cl, Cl. Now see, these bonds are called shared pairs or bond pairs. These lines are called shared pairs or bond pairs. So shared pairs or bond pairs in ammonia, this is called, and H3 is ammonia, and this is phosphorus trichloride. Okay, so there are bond pairs. How many bond pairs are there? 3 unshared pairs, or we can say lone pairs equal to 1, or 3 unshared pair or lone pair in ammonia is equal to 1. Same is the case with PCl3. 3 bond pairs, 1 lone pair. Means this pair which is not shared with any other atom, that is called unshared pair. And how many unshared pairs are there? 1. But when we write H2O, in H2O there are, tell me, how many shared pairs and unshared pairs are there? There are 2 bond pairs and plus 2 lone pairs, or we can write 2 shared pairs or 2 unshared pairs. See, this line is called shared pair because it is shared between oxygen and hydrogen. It is also shared between oxygen and hydrogen, but these 2 are unshared pairs. There is no other atom which share this pair. That's why they are called unshared pairs or lone pairs. Molecular ions. Like CO3 2 negative, carbonate, SO4 2 negative, sulfate. This is called carbonate ion, and this is called sulfate ion. Now in carbonate ion, number of negative charge means number of single bonds. Two negative, so 2 single bonds with oxygen, and oxygen is divalent, oxygen form 2 bonds, but because there are 2 negative, that's why there is single bond with 2 oxygens. So this oxygen is like this, and this one, it is like this. Oxygen has 6 electrons, 1 is shared, so it should have 5 electrons, but because there is 1 negative, there is 2 negative, so 2 negative are attained by 2 oxygens, 1 negative each, okay, for each oxygen. So in this way, this is the structure. What about sulfate? In sulfate there is again 2 negative and total oxygen are 4. So 2 oxygens form single bond and 2 other oxygens form double bond. 2 single and 2 double. And each oxygen should have octet of electron. So It is like this. How do we write Lewis structure for simple molecules? Molecules or ions. What are the steps involved? That I will explain to you now. First step is count number of valence electrons. For example, let us take the case of, okay, in CO, total number of valence electrons is carbon has 4 valence electrons. Okay, valence electron oxygen has, atomic number of oxygen is 8. So 2 for helium and rest 6. Total valence electrons are 10. This is the first step. Whenever we have a molecule or ion, we will calculate total number of valence electrons. Step 2. If a species is cation, then subtract number of electrons equal to magnitude of positive charge from total number of valence electrons. For example, if we have NH4 1 plus, we have NH4 1 plus. You know, total valence electrons to calculate, you know, nitrogen has 5 valence electrons. Each hydrogen has 1, but there are 4 hydrogens. So 4 into 1, and magnitude of positive charge is 1. So subtract 1 from it. So total number of valence electrons comes out to be 8 now. Okay. Step 3. Step 2 means it is, if it is not a cation, we will skip step 2. We come to step 3. If species is an anion, you know, anion means negative charge, then add number of electrons equal to the magnitude of negative charge, equal to the magnitude of negative charge from total number of valence electrons. Okay, so that means step 1 is for neutral molecules, step 2 is for cation, and step 3 is for anion. Okay, so for example, if we have NO2 negative, Tell me total number of valence electrons. Nitrogen has 5 valence electrons. Oxygen has 6 valence electrons. And what is the magnitude of negative charge? 1. So we add 1 in it. So 12. Total 18. Yes, tell me about CO3 2 negative. See, there is 1 carbon, 4 electrons, 3 oxygens. Each oxygen has 6 electrons, and add magnitude of a negative charge. So magnitude of negative charge is 2. So plus 2. 18 plus, yes, it is 24. Very good. So for neutral molecule, we will skip second and third step. There is only first step. If we have cation, we will skip first step, come to the second step. We will skip first and third step. For an anion, we will skip first and second step. Okay, so these 3 steps are for different type of species. For a neutral molecule, we will do by first step only. If we have a cation, second step is applied. If we have anion, third step is applied. Okay, we skip other steps. Okay, now after getting total number of valence electrons, we will select the central atom. Step 4. Select the central atom. Central atom single atom in the molecule or atom of low electronegativity. Atom of low electronegativity. For example, if we have carbonate, what is the central atom? Which one is the central atom? Yes, in this case, carbon is central atom. Okay, and in case of NO2 negative, which one is central atom? Yes, nitrogen. So, sorry, nitrogen. Okay, and what about NH3? Ammonia, again nitrogen is central atom. Okay, then H2O is oxygen. This is an intelligent guess, right? To select the central atom, and these are the qualities. After selecting the central atom and attach the other atom with central atom initially by single bond. Initially by single bond. Okay, so this is the fourth step. Like if we have carbonate 2 negative, so we will write carbon in the center and single bonds for other oxygens. Okay, like we have NO2 negative, we will write nitrogen in the center and oxygen like this. Okay, then rewriting this. Step 5. Now in step 5, complete the octet of each atom by writing appropriate number of shared pairs or unshared pairs by simply write by number of shared pairs or unshared pairs. Okay. Now this is the theoretical, these are the theoretical steps. Now these are the 5 steps. Now we will write, let us take carbonate. Okay. Total valence electrons are 24 that you have calculated. Okay. After calculating this number, you know, carbon these are the oxygens. Now you know this carbon has how many valence electrons? This carbon has 4 valence electrons. Only 3 are used. So one of the oxygen should be double bond. So all the electrons of this carbon are used up now. All the electrons of this carbon are used up. So this is like this. This carbon and oxygen, there is a double bond, and at the same time, how many electrons left? 4. So carbon has octet of electron. This oxygen also has octet of electron. What about these oxygens? We left with 3, 3. So this is the overall Lewis structure of carbonate. This carbonate, number 2, 3, 4. Total shared pairs are 4. And number of unshared pairs 1, 2, 3, 4, 5, 6, 7, 8. Unshared pairs are, shared pairs are 4, unshared pairs are 8. See, calculate total valence electrons. There are 10. Now, to complete octet of each atom, okay, each atom should have 8 electrons. So, in CO there are 2 atoms. So, 2 into 8 is total 16. So, shared electrons now equal to total electrons required to complete their octets minus valence electrons. Yes, this is the right formula. Stamp लगा लो इस पे. So there comes out to be 6, and shared electrons equal to shared electron divided by 2, that is 3. We will use the same formula for carbonate as well. Okay. Now unshared electrons, that is equal to valence electrons minus shared electrons. Valence electrons minus shared electrons. So 10 minus 6, that is 4. So unshared electron equal to, unshared pairs equal to unshared electrons divided by 2. So that comes out to be 2. That's right. See, first calculate valence electrons. then number of electrons required to complete the octet of each atom, that is always equal to number of atoms into 8. Okay, then shared electrons equal to total electrons to complete octet of each atom minus valence electrons. Okay, so shared pairs equal to 3. Unshared electrons, out of valence electrons subtract the shared electron, so we get 4 number. So unshared electron equal to 2, unshared pairs equal to 2. Let us apply the same for carbonate. In carbonate, valence electrons are 24 that you have calculated, and total electrons required to complete the octet of each atom is equal to, how many atoms are there? 3 oxygen, 1 carbon. 4 into 8, so 32. So shared electrons equal to electrons required to complete the octet minus valence electron, that is 32 minus 24, that is 8. So shared pairs equal to 8 by 2, that is 4. Okay, now unshared electrons equal to valence electrons minus shared electrons, that is 24 minus 8, that is 16. So unshared pair is equal to 16 by 2 means 8. That's right. So this formula is used. First calculate valence electrons, then calculate total number of electrons to complete octet of each atom, then shared electrons, then shared pairs, unshared electrons, unshared pairs. Okay, so let us apply it for NO2 negative. So for carbonate, for carbon monoxide, there is carbon and oxygen only. There are 3 shared pairs. So there are 3 shared pairs and 2 unshared pairs. So one with each atom, and we get this type of structure. Okay. Now let us apply it for NO2 negative. Calculate for NO2 negative by applying the same formula. Valence electrons, 5 from nitrogen, 6 from each oxygen, and plus 1 for negative. So total 18 valence electrons. Now electrons required to complete the octet of each atom. How many atoms are there? 2 oxygen and 1 nitrogen. 3. And to complete octet means 8 electrons in each atom. So total 24. Shared electrons equal to total electrons to complete octet minus valence electron, means 24 minus 18, that is 6. So shared pairs equal to 3. Very good. And what about unshared pairs? Okay, before, okay. And unshared electrons equal to valence electrons minus shared electrons. Valence electrons is 18 minus shared जो है 6, so 12. So shared pairs, unshared pairs equal to unshared electron divided by 2. 12 by 2 means 6. Now nitrogen is central, so there are oxygens. Shared pairs are 3. So how to distribute? 2 1 2 1 or 1 2. You can write 2 1 or 1 2. Total shared pairs are 3. So you can distribute like this only. Because if there are 4, you can write 2 2 or 3 1 or 1 3. But if there are 3 only, there is only one option. That is 2 1 or 1 2. And whole negative. So tell me, how many lone pair I will attach to this? This oxygen has total 4 electrons, 2 plus 2. So it need 2 more to complete its octet. What about nitrogen? How many lone pair I will attach? For nitrogen I will attach 1 to complete its octet. Because 1, 2, 3, 6 electrons already it has. So 2 more electrons are required. But this oxygen 3. So see 1, 2, 3, 4, 5, 6. Here 3, 1, 2. That's it. Write Lewis dot structure of CO2.